Hello, everyone. In this recitation, we're going to walk through a practice problem that is going to be representative of what you can expect to see on exam 1. The problem reads, small droplets of carbon tetrachloride at 68 degrees Fahrenheit are formed from a spray nozzle. The average droplet diameter is 200 micrometers. Determine the pressure difference between the inside and outside of a droplet. And we're given the surface tension of carbon tetrachloride and a conversion rate from micrometer to feet. The first thing I like to do with these problems is read through them and see what kind of problem it is. For this one, I can tell it's a surface tension or capillarity problem. That's because it says things like droplet, we have small droplets, we have a droplet diameter, and the fact that we're given the surface tension. So we can tell that we're using something to do with surface tension. And since it asks for the pressure difference between the inside and the outside of the droplet, I can tell that it's a surface tension problem. So since it's asking for the difference between the inside and outside, it's asking for a difference of pressure. That's delta P, and that's the difference between P inside and P outside. The textbook version of this equation looks like this. Delta P equals sigma times open parenthesis 1 over radius 1 plus 1 over radius 2 close parenthesis. Since we have a droplet, there is no inside and outside radius. There's just only one radius. So we can reduce it to this other form, delta P equals 2 sigma over R. We're using radius, but there is the other form where you can use diameter. So since diameter is the same as saying 2 radius, the numerator increases also by a factor of 2. So now it's 4 sigma instead of 2 sigma. These are two pretty important equations, so I went ahead and highlighted them just so that it's pretty easy to identify. Next from the problem, I like to remove all the fluff and just keep what we really need. So we're given a diameter, 200 micrometers, and a surface tension of carbon tetrachloride and a conversion factor. I'll begin by converting the diameter into a radius because I want to use the form of the equation that uses R instead of D. Of course, we know radius is diameter divided by 2 because radius is half diameter. When we divide 200 micrometers by 2, we get 100 micrometers. Next, I want to convert the 100 micrometer radius into feet. We'll use the given conversion factor and multiply radius times 3.2 times 10 to the negative 6 over 1. So that gives us our radius in feet is 3.2 times 10 to the negative 4 feet. Now that we have everything in terms of feet, our surface tension and our radius, we're going to use the Laplace pressure for a spherical droplet, which is the equations that we talked about towards the beginning. Delta P is equal to 2 sigma over R. We have that equation, so we can just substitute our values in. We're looking for a change in pressure, so we want to make sure that our units are correct. Since we have pound-feet in the numerator, that turns into pound-feet squared, which is a force over an area, which is a valid unit for pressure. So our final answer is 11.25 pounds per feet squared. That's our final answer. Well, thank you guys for watching. Make sure that you find the other videos, the other recitation videos, and watch those as well.